Hi everyone, in today's lesson we're going to talk about the definite integral, but this time below the x-axis. So we know that the definite integral is the area bounded by the curve in the x-axis over a given interval. But what the new piece of information is that the value of the definite integral below the x-axis will be negative. We haven't done any examples like this yet, so I'd like to talk about one now. So in example number one, we have a picture of a graph. Region A, B, C, D, and E in the figure below are bounded by the graph of the function and the x-axis. The area of region A is 8. So I'm going to go ahead and label that. A is 8. The area of region B is also 8. The area of region C is 5. And the area of region D is 11. And the area of region E is 13. So they want to know what is the value of this. So remember, this means area between the curve and the x-axis. So area between curve and x-axis from the interval of -8 to 8. So what we learned is that a definite integral below the x-axis, those will be recorded as negative. So I'm going to use colors to highlight. So anything above the x-axis, I'm going to highlight in yellow. That's going to be positive. And then anything below the x-axis, I'm going to highlight in blue, and that's going to be negative. So if you want to label that, you can. These three will be positive. And these two, since they're below the x-axis, will be recorded as negative. So I want the area from -8 to 8. So what we would do is we're just going to start by taking the 8, and then we would subtract this 8, add this 5, subtract the 11, and add the 13. So 8 minus 8 plus 5 minus 11, and then plus 13. So you could throw this into the calculator, or we could just do it in a couple of stages. We know that 8 minus 8 in order will give us 0. 5 minus 11 will give us -6. And if we add 13, we'll get a +7. So the entire area over that interval should give us 7. So a couple things to notice. If this is 8 and this is -8, it seems as though these two areas are the same thing, and they're just going to cancel each other out. So that's something that I'd like to discover in the next example. So we've got example number 2. So what I'd like to do is calculate from -3 to 3. It means to calculate the area between the x-axis and the curve of x to the third between those values. So I want to estimate this using left Riemann's sums. So let's first draw a picture. So we've got x to the third. You can put that into your calculator, and if you do, you're going to get this and this. And I want to estimate from -3 to 3 using 4 subintervals. So just for simplicity, I think I want to change this to 6 subintervals. So let's first find the width. So the width is b minus a over n, where this is b and this is a. So 3 minus -3 all over the subintervals n, which is 6. So 6 over 6 reduces to 1. So a width of 1 will help us. So we're going to count 1, 2, 3, and then 1, 2, 3 negatively. And I want to use left Riemann sums. So that means I'm going to start from the very, very left of the interval, which is here at -3. And we're going to go down to the curve, and then we're going to go over. Same thing, go down to the curve, and then go over. Go down to the curve, and then go over. Now at 0, there's no curve to go up or down to, so it's almost like we're going to skip this one. This would be almost like a flat, no rectangle. Then at 1, we go up to the curve, and we go over, up to the curve, and then go over. So it's weird that we're going down, but it's still the same kind of concept, right? So from here, we need to take 6 of these rectangles and add them together. So 1, 2, 3, 4, 5, 6. Now be careful when you get here. There's no height there, so there's no area, right? So this is just a line, it's not a rectangle. So what we want to do is we're going to use -3 for the height of this rectangle. We're going to use -2 for the height of this rectangle, and -1 for the height of this one. We're going to use 1 for the height of this, and 2 for the height of that one. We're not going to use the 3. So take a minute, use your calculator, find the values, and then hit resume when you're ready for the area. All right, this is what I got. So -27 units squared. Think about that. You're finding area between the curve and the x-axis. That doesn't make any sense, right? And here's the reason. The reason why is because if you're asked to calculate the area, you don't want to use the negative numbers. You want to consider thinking of the absolute value because area can never be negative. So really this one should really be 1 times 27, which is 27. And this one should be 1 times 8, which is 8. And this one should be 1 times 1, which is 1. And obviously 1 times 1 again is 1. And then 1 times 8 is 8. So if you add this up, this is actually going to give you a different area. So add 27, 8, the 2 ones, and 8, and then see what you get. Okay, so you should be getting now 53 units squared. So that makes more sense. It's a positive value, right? Area under the curve. So in this instance, you really need to take, like I said, the absolute value of these, right? Because the area under the curve is this spot in here, this area from here to here to here, all the way up, right? That's my area under the curve. So this guy is not your answer. So now I'd like to use the definite integral by hand and actually find the exact area. So we're going to do now. Rewrite it from -3 to 3 of x to the third dx. So we're going to add 1 to the power and divide by that power. And we're going to evaluate from -3 to 3. So remember, we're going to do top minus bottom. So the top and bottom, we're going to subtract. So I'm just going to leave some space to fill in. So the top, we're plugging in 3. So 3 to the 4th over 4. And then the bottom, we're going to plug in -3 to the 4th over 4. So take a minute, plug these into your calculator separately, and then subtract them. And then hit resume when you're ready for the answer. All right, this is what I got. So 20.25 minus 20.25, and this gives me 0. So that means there is 0 for the definite integral. And let's explain why. Let's see the difference between part A and part B. So if I have my curve, right, we know it's an x to the third curve. So we've got this and we've got this from -3 to 3. What the definite integral does is it actually gives you the exact area between the curve and the x-axis. So it would go from here to here without going over, and from here to here without going over. And if you notice, that area is identical. And as we learned in the first page, this area should be positive and this area should be negative. So it's not going to be an over approximation or an under approximation. It's going to be exact. And in this case, if this is positive and this is negative, it's just going to cancel out to 0. And if you look at your left Riemann sum, look at this. This is an over approximation here and then an under approximation here, because theoretically we needed to go to 3, right? And I'm missing all of this space up here. So I'm missing this, this, and this is over, over, over. So area between the curve is just going to calculate the rectangles from here to here and here to here. But the definite integral is going to calculate the exact area from here to here and from here to here. But it's going to calculate below the x-axis as negative and above the x-axis as positive. All right. So the last question is, why would this question never ask you to find the percent error in situations like these? So I'm going to let you guys think about that one. Fill it out what you can for homework, and then we'll start there tomorrow in class. All right. Have a good night.